Hello and welcome to the June webinar from the IEA Clean Coal Centre. My name's Stephen Mills and I'm a Senior Analyst and Author at the Centre. Our monthly webinars are based on our technical reports which are available from our website at www.iea-coal.org. After a one-off registration, residents of member countries and employees of sponsoring organisations can download our reports free of charge. Please visit our website for details. Now, today's webinar is based on my latest report, which looks at combining solar power or natural gas co-firing with coal-fired power plants. In this, I've looked at several technologies that show potential for improving the operation and reducing the environmental impact of at least some coal plants around the world. So, the report explores ways to potentially improve plant flexibility by combining solar power with coal or adopting natural gas co-firing. It will be published shortly and will be available on our website. If you have any questions during today's presentation, please use the Ask a Question box at the top of your screen. Add your email address as well so I can send you a fuller answer if we run out of time or if a more detailed response would be appropriate. Now, although in some countries the use of coal is diminishing, in others it's still vital for providing reliable, affordable electricity. Virtually all major economies rely on coal to some extent, and many emerging ones do the same. Despite competition from other generating systems on a global basis, coal will retain its importance for many years. But clearly, the more it can be used, the better, and efforts to minimise any environmental impacts are growing. And in many countries, tougher environmental legislation is being introduced aimed at minimising levels of classic pollutants and CO2. Now, a further complicating factor is that often, coal plants were designed to work predominantly on base load, and many no longer have this luxury. An increasingly competitive marketplace means that they're now forced to operate on a much more flexible basis. Regular start-stops, load following and low-load operation have increasingly become the norm. Now, this is often to compensate for the fluctuating input that comes from intermittent renewables such as wind and solar power. Despite their inherent variability, electricity from these sources is frequently given priority over that from thermal power plants. So in the face of this, to remain competitive, coal-fired fleets are having to adapt to meet the changing circumstances. Increasingly flexible operation is a key factor, and plant operators continue to explore possible routes to achieving this. They're looking for ways to increase the efficiency and extend the working lives of their plants by improving operational flexibility and reducing their environmental impact. And with this in mind, I was asked to look at two possible options. And as we've heard, these were combining solar energy with coal-fired power generation and co-firing natural gas in coal-fired power plants. These two topics were explored through a comprehensive survey of projects around the world, along with input and opinion from a number of plant operators and developers and suppliers of both types of technology. Now, the first question to consider was, why would you even want to think about combining these apparently disparate forms of generation? And just how might they be combined with coal in such a way as to create effective, affordable power generation systems, importantly with a reduced environmental impact? Well, given that these individual technologies are very different in many ways, could they successfully be integrated to form viable systems that will help coal sustain a major role in generating a significant proportion of the world's electricity? Now, at first glance, these two particular topics might seem to have little in common. However, there are some commonalities, and under the right conditions, each has shown the potential of being integrated into at least some coal-fired plants, allowing them to operate in a more flexible and cost-effective way. At the same time as both could effectively replace part of the plant's coal feed, they also have the potential for curbing emissions, as well as for reducing plant costs in a number of areas. Now, in a number of countries, coal-fired generation is currently facing some significant hurdles. As we've heard, not only do plants have to meet tougher emission limits, they're now expected to do this while operating in ways that they were never really designed for. Some of the world's cheapest electricity has long been generated by coal-fired plants, but the move away from baseload to more flexible modes of operation can impact on a number of areas of a plant, making it even more difficult to maintain efficiency and profitability. As a result, operators are constantly on the lookout for new ways in which to maintain or improve the performance of their plants, as well as possibly extend their working lives. If a particular plant is shut down, well, the local economy is going to suffer. Jobs will be lost, not just within the plant itself, but also in the coal mining sector that supplies it. Bad enough, but perhaps more important is the fact that often the plant may still be capable of consistently generating electricity more cheaply and reliably than some competing sources. And, depending on where you are in the world, there may be a pressing need for this electricity. But of course, there can be obvious environmental issues that need addressing. Even though many improvements have been made to coal-fired plants, there's still a need to reduce their environmental impact further. Anything that can be done to reduce levels of classic pollutants and CO2 is clearly welcome. So it's against this background of competition and efforts to reduce environmental impact that utilities have increasingly sought ways to boost efficiency and minimise emissions. Which brings us to the first topic explored in this report: coal-solar hybrids. Now, when it comes to integrating solar thermal power with coal, there are several possible options. When it's available, it's possible to use solar energy to replace part of the plant's coal feed. And this is usually termed coal-saving mode. So, by effectively replacing some coal, it's possible to generate the same amount of electricity but using less, and this can bring a number of economic environmental benefits. With the second, solar boost mode, it's possible to use additional steam produced by the solar system. This can be incorporated into the power plant's steam cycle and fed through the steam turbine, so boosting output. So it's possible to generate more power, but using the same amount of coal. So solar boosters, as they're sometimes called, can increase capacity in generation without additional coal consumption and with virtually no additional cost other than that of the solar field itself. And of course, there may be the possibility of doing both. Depending on the particular situation, and the ratio between the two modes of operation can potentially be changed as required. But whichever of these systems is used, in poor weather or at night when there's no sunshine, there's clearly no input from the solar system, so the plant reverts to 100% coal-based operation. Now, solar energy for thermal applications can be harvested in a number of ways, but whichever system is used, most channel heat into a heat transfer medium, such as mineral oils or molten salts, from where it's normally used to raise steam that can be fed into different parts of a power plant's steam cycle. The main types of solar collection systems are the ones shown here and comprise parabolic troughs, where solar energy is concentrated using parabolically curved trough-shaped reflectors onto a receiver pipe that runs along the inside of the curved surface. Then there are linear Fresnel systems. These are an alternative that rely on the use of segmented mirrors instead of troughs. And finally, there are power tower systems, where a power tower or central receiver uses sun-tracking mirrors called heliostats to focus sunlight onto a receiver at the top of a tower. So there are a number of solar collection systems available commercially, and some are more effective than others. Systems that use two-axis tracking to follow sunshine onto and focus it onto a single point receiver, and we're talking mainly about power tower systems here, are more efficient than linear focus variants. They tend to operate at higher temperatures, so where they do form part of a CSP plant, they can generate power more efficiently. However, the downside is they're also more complicated to construct and operate. Now, exactly where the steam produced is fed into an existing power plant will depend at least partly on the type of solar collection system used, as these tend to operate at different temperature ranges. But this table shows you what some of the possibilities are. The schematic shown here is a simplified example of solar energy being used to heat boiler feed water, so far the most common application. Now, projects can be very site-specific, and so a particular combination of pluses and minuses on site might not apply exactly to one located somewhere else. But in general, these are some of the main points often cited. It gives an indication of the major points that have been highlighted by project developers. Some are self-evident, so we won't go through each individually, but suffice it to say, although renewables such as solar and wind power are attractive on environmental grounds, they face a major challenge, namely their inherent variability. Potentially, an elegant solution can be to combine solar with coal-fired generation. Such a partnership can bring the environmental benefits of solar, but offers the advantage of shared costs of major plant equipment. In a retrofit situation, most of this will already be in place as part of the coal-fired power plant. So, combining these two types of generation within a single power cycle can capitalise on the strengths of both. But of course, there'll also be drawbacks, some of which are fairly obvious. Perhaps first and foremost, the site needs to get plenty of intense sunshine for extended periods, both on a daily and yearly basis, and depending on where you are in the world, this clearly isn't always the case. Perhaps one of the most important factors affecting coal-solar hybrids is that so far, input from the solar side has tended to be somewhat on the low side. And this is largely because projects have been based on retrofitting existing coal-fired plants. As a result, practical issues have tended to limit the solar contribution to perhaps around 5% or less. Useful, yes, but it could be substantially greater. Some developers suggest that if a new power plant was designed and built based on the hybrid concept from the outset, up to 30 to 40% solar share would be realistic. So each potential project brings its own combination of pluses and minuses. And although there are certain areas that will be common to all, there'll also be factors that will be specific to each individual site. So projects need to be examined on a site-by-site basis. What might apply in one location won't necessarily apply in another. Which brings us to the Cameo station. Well, this is what's considered to be the world's first true coal-solar integration hybrid power plant. This was built in Colorado in the USA, and it really started the ball rolling in this area of technology. Set up as a demonstration project, it operated in 2010 and formed part of an initiative that was designed to test promising new technologies that showed potential for reducing greenhouse gas emissions, as well as producing other environmental improvements. It used sun-tracking parabolic trough technology to supplement the use of coal. Heat harvested by the solar collection system was focused on a heat exchanger that used to preheat feed water supplied to one of the Cameo plant's 2 coal-fired units. It was expected that hybridisation in this way would produce a number of environmental and economic benefits. Now, an important factor was that incorporating solar into an existing power plant meant that it was a cheaper option than building a new standalone solar thermal facility, as it avoided the extra cost of things such as steam turbine generator and other power block equipment that would otherwise be needed. All of this was already in place and available, and indeed this is considered a major advantage of coal-solar hybrids in general. Overall, at the end of the demonstration period, the Cameo project was deemed to have been a success, showing that under the right circumstances there was the potential for creating an effective, workable combination between solar and coal. When in use, the plant operated without problem. Less coal was used, so coal costs were reduced, as indeed were emissions to air and other waste streams. Now, so far, it hasn't led to any further commercial scale projects in the USA. However, this may be due, at least in part, to the difficult market situation and uncertain future that many coal-fired plants currently face in the country. Which takes us to this project. Now, although the Cameo plant hasn't yet led to any new hybrids in the USA, projects such as this have been useful in confirming that the combination of technologies can be made to work effectively. And there are a number of projects, not many admittedly, that are in the pipeline. For example, this particular one is being developed in northern Chile. At the moment, the country already has several standalone solar plants, and this hybrid to be located at this existing coal-fired power plant is set to join them. The plant's located in a region that gets a lot of intense sunshine, so you can see the attraction of this particular location. It hires various types of imported bituminous coals and has a total capacity of 320 megawatts. The solar setup is to be integrated with a 150 megawatt subcritical unit, and we use a compact linear Fresnel reflector system to generate superheated steam through a solar boiler. The project's being developed in an important mining region that urgently needs more electricity, and the main aims here are to boost the output of the plant, as well as reduce its CO2 emissions and coal requirements. It seems a reasonable bet that the successful demonstration of the technology here could lead to its replication elsewhere within Chile, and indeed in other countries. Now, in the report, I've looked at what's been done in the past, what's being developed at the moment, and what's planned or proposed for the future. The countries I've mainly concentrated on are these. Now, clearly the extent of development activity has varied widely, so a lot of practical work's been undertaken in, for example, the USA, Australia and South Africa, whereas in others it's been rather more limited. However, some new developments are now nearing commercial reality. For example, we've just mentioned the hybrid project being developed in Chile, and if this proves successful, there seems a real possibility it could be replicated elsewhere. I mentioned earlier that the solar input tends to be rather modest in retrofit situations, and this is the case with the Chile project, with the solar component producing around 5 megawatts. But, as they say, every little helps. It will all help build up a useful base of operating experience. So what are the prospects, and how might we see coal-solar technology progress in the future? Well, as we saw from the earlier table, there are a number of factors that work in its favour. For example, sunshine is essentially free, and solar power produces no emissions to speak of, so as a renewable form of energy, it tends to be viewed favourably by the public. Development work is continuing in a number of areas, and there are advances being made to solar collection equipment, heat exchangers and thermal storage systems, to name a few. All of these have the potential to improve the overall performance and reduce the cost of a hybrid. As part of this, some technology suppliers are developing reference designs and standardised modular systems and components that should help drive costs down. Now, we haven't really mentioned thermal storage yet, but this is likely to become increasingly important for solar thermal-based projects in general, but not necessarily for all coal-based plants. It's assumed that with some, operators will opt to simply ramp up the coal plant when input from the solar system drops or is unavailable. But other suppliers consider that thermal storage will be absolutely essential in meeting the need for flexible power plant operation. In the end, it will probably come down to cost. Now, some utilities and developers consider there could be a significant market for coal-solar hybrids and have suggested that the technology offers an opportunity to install what they consider to be the lowest cost form of solar power. To date, much of the focus has been on retrofitting of solar power to existing coal-fired plants. However, industry opinion considers that the real potential lies in its integration with new, more efficient plants using higher steam conditions. It's been suggested that under the right conditions, a large coal-fired power plant could be capable of absorbing between 200 and 400 megawatts of solar thermal power, much more than current retrofit projects. So what are the main points that have come out of this study? Well, in the grand scheme of things, for a number of reasons, it doesn't seem very likely that coal-solar hybrids will have a major impact in global energy markets. And at the moment, although there are various proposals being considered around the world, there aren't many major projects actually at an advanced stage of development. A factor that probably hasn't helped is that some earlier projects have had issues. Although some have had a degree of success, problems have ranged from unspecified technical difficulties through to lower than expected plant improvements. But a major issue has often been project finances and the inability to keep costs to what's been considered an acceptable level. At least one major project has even been abandoned partway through construction because of a combination of technical and financial issues. Elsewhere, projects have been proposed, but developers have been unable to make the finances stack up, so most haven't, at least as yet, proceeded beyond feasibility studies. But having said that, it's not all doom and gloom, as under the right conditions, hybrids certainly show potential. And this is helped by the fact that usefully, as we've heard, there are different configurations possible, so potentially a plant can save coal or increase output or even both. But more importantly, as we've heard, industry opinion is that a plant specifically designed as a hybrid from the outset could accommodate much more solar energy than most retrofits. What is clear is that any project is likely to be very site-specific, so in practice, each will need evaluating very much on a case-by-case basis. Now, in the second part of the report, the possibility of co-firing natural gas in significant amounts in coal-fired plants is examined. Both coal and gas-based generation are vital in powering many of the world's developed and emerging economies. Depending where you are, both may be used heavily to provide a secure and uninterrupted supply of electricity needed to ensure that economies and societies can develop and prosper. In some countries, coal provides much of the power, whereas in others, gas dominates. However, there are many instances where the national energy mix includes combinations of the two. Now, each brings its own well-documented advantages and disadvantages, and recent years have seen a growing interest in ways that these two fuels might be combined in an environmentally friendly and cost-effective way. Now, although many coal-fired power plants around the world already use natural gas for start-up in warm conditions, the amounts used are usually relatively limited. But why would you want to co-fire gas in larger amounts? What sort of benefits might it provide? Well, as we heard earlier, changing market conditions are increasingly forcing many plant operators to find new ways to operate their plants so as to keep them clean, efficient and economically viable. And important tools in meeting these requirements can be fuel and operational flexibility. And here we're talking about effectively replacing part of the coal feed with gas and burning the two together in a plant steam generator. Now, in many countries, environmental legislation continues to be introduced to reduce levels of SO2, NOx, particulates, mercury, and more recently CO2. So increasingly operators are facing the dilemma of what to do with their coal plants. Now there are several possible options. They might simply decide to close the plant, or alternatively they may need to invest heavily in upgraded emission control equipment. There are a lot of plants in the USA, for example, that are currently in this situation. If finances allow, they could possibly opt for the complete conversion to 100% natural gas firing, but this could be too expensive or impractical. Alternatively, they may be able to modify the plant so they can add natural gas in some way that help keeps it in service. Co-firing with gas in this manner looks a promising option for at least some existing coal-fired plants, and a number of utilities are considering or even in the process of converting their coal plants for co-firing, enabling them to stay in operation but now using a mix of coal and natural gas. Importantly, some conversions allow the ratio of coal to gas to be altered, and as such they provide a useful degree of flexibility in terms of fuel supply and operation. Now, as with solar addition, there can be various pluses and minuses involved. Some of the main attractions of co-firing are these. We don't have time to go into them today, but as you can see, there are a number of areas where plant operations can potentially be enhanced, emissions reduced, and even cost savings made. Now, potentially, there are a number of ways in which natural gas can be added to an existing system. Some replace a portion of the main coal feed, where more focused on using it to minimise emissions of species such as NOx. So, some possible options include, well, preheating the coal prior to combustion. Usefully, preheating using gas-fired burners has been shown to help minimise NOx formation. And of course, gas can also be used as a reburn fuel to again reduce NOx. But the amounts of gas used for this types of application will normally be less than if the plant is converted to actually co-fire gas in the true sense. This allows much greater amounts of gas to be fed into an existing boiler and burned simultaneously with the coal feed. Now, depending on the individual plant and the operational requirements, there are a number of possible ways to configure the existing unit so that co-firing becomes a practical proposition. It may be a case of replacing oil-fired igniters or warm-up guns with gas-fired equivalents, probably one of the simplest options. But should a plant operator wish to consistently put even more gas through its plant, it's likely that gas firing will need to be incorporated into the main burner systems. And there are now dual or multi-fuel burners suitable for this, available commercially from a number of suppliers. And this simplified schematic here shows you one example from an American producer. So, co-firing has quite a lot to offer, but of course, it's never that simple. An obvious requirement is that the power plant has an adequate source of gas available at an accessible price. If gas is already being used for warm-up operations, reburning and so on, some of the existing systems may be suitable. If not, additional supply and control equipment will be needed. If there's no existing gas supply, depending on its overall length and taking into account any local constraints, costs for a new gas pipeline can be considerable. A further complication could be that in some locations, the amount of gas available might be limited, or there could be also seasonal restrictions where priority is given to other applications, or it might simply be too expensive. And of course there will be various technical issues that will need addressing. For example, differences in flame temperature, gas mass flow and so on can create the risk of heat transfer imbalances. Other potential problem areas can include gas burner placement, heat transfer and heat transfer services, and all need to be taken into account. And here are a couple of examples of coal-fired plants that now regularly co-fire natural gas. The one on the left is the Gaston power plant in the USA, where last year Alabama Power converted one unit so that it now starts up using gas, as well as co-fires. It can now fire gas up to 2/3 of its rated capacity. Usefully, this arrangement helps the plant meet federal emission standards as well as increases its operational flexibility. Co-firing is increasingly viewed as a possible response that would allow some existing plants to meet the necessary environmental and economic criteria and so avoid closure. At the very least, it could extend the working lives. Industry opinion is that in the future, operating advantage will go to utilities with diversified fleets, those which have the ability to capitalise on whatever the cheapest fuel is at the time. And coal-fired plants could form an important component of this. Now, apart from North America, there's also potential in some other parts of the world, but what makes the US market so different is the current glut of cheap gas. In the past few years, prices have been at historically low levels, and this is likely to continue to be a major factor in any such equation. Of course, this isn't necessarily the case in other countries where gas may be too expensive or simply unavailable. But having said that, there are some plants that co-fire and others that are considering it. And this is just one example on the right. It's the 4 gigawatt coal-fired Suralaya plant in Indonesia, where one newer unit now relies on both coal and gas in varying amounts. So there's no over-dependence on a single source of fuel, and this fuel flexibility can be a real advantage, especially in an increasingly competitive marketplace. So what have the main findings been? Well, both coal and gas-based generation are vital in powering many of the world's developed and emerging economies. And recent years have seen a growing interest in ways that these two fuel sources might be effectively combined. Although many coal-fired power plants around the world already use gas as startup in warming operations and possibly for NOx control, the amounts used are usually quite limited. As we heard earlier, changing market conditions are increasingly forcing many operators to find new ways to operate their plants so as to keep them clean, efficient and economically viable. And important tools in meeting these requirements can be fuel and operational flexibility, and coal firing could play a useful role here. Potentially, the technology can bring some useful advantages to the table. Suffice it to say, it does have the potential to provide some environmental and economic benefits. These could even be enough to make the difference between allowing certain plants to avoid early closure. So co-firing certainly looks a promising option for at least some coal-fired plants. Importantly, some conversions allow the ratio of coal to gas to be altered, and as such, they provide a useful degree of flexibility in terms of fuel supply and operation. And this clearly opens up the option of capitalising on whichever the cheapest fuel is at the time. Co-firing also means that coal plants can start up more quickly, and it makes it easier to load follow and operate at lower loads than would be possible firing coal alone. So operational flexibility can be significantly improved, as we've heard, an important factor. But at the end of the day, to be a practical proposition, you need a reliable source of natural gas available at an acceptable price. Ideally, as in the USA, gas needs to be relatively cheap, and of course elsewhere in the world, that's not necessarily the case. So what are the future prospects? Well, we've established already that around the world there are various types of coal-fired power plants that use gas regularly as part of their normal day-to-day operations. The largest numbers are in the USA, where there's an estimated 27 gigawatts of coal-fired plants that uses gas in some way. There are also other countries that operate more modest numbers of coal plants, and some of which have the potential for coal firing. But the biggest near-term potential undoubtedly lies in the US power sector, where a number of major generators are at various stages, either evaluating or even installing coal firing capabilities. Others are playing a waiting game, watching to see how well these first projects perform. So what does this mean for the future of coal? Well, in the case of solar, in some situations, addition of solar power would actually reduce the coal consumption. I mentioned earlier that there are several possible ways for a coal-solar hybrid to be run. So, if it was operating in coal-saving mode, where solar effectively replaces part of the coal feed, as its name suggests, coal consumption would be lower. If operating in boost mode, where solar energy is used to increase plant output, again, coal consumption won't go up from the baseline. However, demand would stay the same. It wouldn't reduce. But having said that, in the right circumstances, it's possible that the addition of solar power could provide enough advantages to a particular plant that might help reduce its environmental impact and improve its overall economics sufficiently to enable it to keep running. And clearly, if it remains operational, it will still need a coal supply. Now, turning to co-firing, well, as with solar, co-firing won't directly increase coal demand. Again, it will tend to reduce it. As the main premise behind the technology is to effectively replace part of a plant's coal feed with natural gas, inevitably coal demand will decrease. But like solar, the addition of gas to a plant's fuel mix can provide some important benefits. It can be a cost-effective route to allowing a plant to work on a much more flexible basis, allowing it to respond more quickly and efficiently to changes in load demand. And at the same time as less coal is being used, plant emissions would decrease. And this could be sufficient to meet relevant emission limits, as well as reduce emission control costs. So again, the technology could potentially improve a plant's performance sufficiently so it could remain in operation. And again, if that happened, it will still need a supply of coal, albeit less. So in both cases, coal demand won't increase, but either technology could provide enough advantages that would allow some plants to remain and operate more flexibly, meet emission limits and improve their cost base, allowing them to remain productive and profitable. Now, with coal-solar hybrids, well, firstly, any solar-based generating system, and that includes hybrids, is obviously limited to places that get consistently enough sunshine. How viable a particular project is will depend on multiple factors. Furthermore, projects need evaluated on a case-by-case basis, as we've heard, as designs can be very site-dependent. Now, unlike PV-based generation, electricity from hybrids is usually considered to be dispatchable. A hybrid plant doesn't depend entirely on the weather. Electricity can be made available when it's needed. So, if solar input goes down, the coal plant can simply be ramped up to compensate for the shortfall. Now, although there can be some technical challenges, none are considered insurmountable. Most plant components and systems are already available, although integration issues will differ between individual projects. In the longer term, the biggest potential market is considered to lie in integrating solar power with new, highly efficient coal-fired power plants. By incorporating it into the design stage, it's predicted that much higher levels of solar energy could be utilised. Now, in the case of co-firing, well, where it's already being done, co-firing has provided utilities with various benefits. Aside from any local issues that might arise, the crucial requirement is obviously a reliable, affordable supply of natural gas. And the lack of this in some countries, or even parts of countries, clearly limits the technology's potential in those places. However, in some, such as the USA, where cheap gas is available in abundance, co-firing appears to offer an important lifeline for extending the working lives of at least some coal-fired plants faced with early closure. Utilities are watching the current ongoing developments with interest, and success here would likely encourage others to seriously consider it. So to close, under the right conditions, adding solar power or co-firing appears to show potential. Depending on the individual circumstances, both are capable of increasing the flexibility of a power plant, reducing its emissions, and possibly reducing costs. But inevitably, as we've heard, their use will be limited to locations that are able to meet the necessary criteria. But both have the potential of allowing a power plant to operate in a more flexible manner and at the same time help reduce its environmental footprint. Now, the need for good solar radiation means that the uptake of coal-solar hybrids will be limited, although co-firing has wider potential. As we've heard, at the moment, the biggest potential is in the USA. However, where gas is available and affordable, there are also potential markets elsewhere. In many countries, coal faces various hurdles such as competition from subsidised renewables and stricter environmental legislation. Factors such as these are making life increasingly difficult for thermal power plants in general, but particularly for those that fire coal. So set against this background, we were asked to consider whether coal-solar hybrids or gas co-firing could help maintain a coal-fired power sector and its associated coal mining industry. Well, realistically, as we've heard, neither form of technology is going to increase overall coal demand of an individual plant, but rather it will tend to reduce it. But under the right circumstances, by reducing environmental impact, improving operational flexibility and reducing operating costs, both offer the possibility of keeping certain coal-fired plants in service, something that otherwise might no longer be a viable option. Thank you very much for your attention. We'll just see if you had any questions coming in. Yeah, we have one here. What do you consider to be the most important advantage a coal-solar hybrid would have over a standalone solar power plant? Well, I think realistically, there are quite a few factors here that we could discuss. There are quite a few reasons why a power company might find coal-solar hybrids more attractive than, say, PV. And in fact, these are discussed at some length in the report. But I suppose one of the biggest factors, if you're adding solar power to an existing coal-fired plant, is the fact that you don't need to buy a lot of new equipment, such as steam turbine and so on. The only major capital cost will be for the solar collection system. Most of the main systems needed will already be in place as part of the coal plant. So obviously, this greatly reduces the overall cost of any new project. It also means that the electricity generated will cost less as these major systems are already factored and available. I suppose the major factor in hybrids' favour is potentially a coal-solar plant can generate electricity around the clock whenever it's needed. So when the sun goes down, output from the coal side of the plant can simply be ramped up again to make up any losses. When the sun comes up, obviously the coal plant can be turned down again. So that's a major advantage that hybrids have over PV systems, is obviously once sunlight's no longer available, electricity from PV simply stops. Having said that, I suppose like any form of technology, there are going to be downsides, and I suppose the biggest of these is you need, well, sometimes quite substantial areas of land next to an existing power plant for siting the solar collection system. If bigger plants, this can run into many thousands of hectares. And of course, as I've mentioned, it's an obvious point, but to be viable, you need plenty of sunshine throughout the year, and clearly that limits the technology to places that do get this. So such a system is not going to make much sense in countries such as here in the UK, where, as we all know, most of the year the sun never shines and it never stops raining. One other question, I think. Oh, this is to do with co-firing. Why don't power companies just switch from burning coal to 100% gas? Given the pressures that coal is facing, wouldn't this be the easiest option? That's a very salient point. In some cases, this has happened, but it's not always that simple. Of course, assuming that gas is available at a good price, there may be technical issues that make it difficult to switch completely. As I mentioned earlier, not all existing coal boilers are capable of a straight swap such as this to gas. There are important differences between burning coal and gas, and this can throw up practical issues. So, for instance, a unit's heat transfer surfaces may not be suitable, or there might be expensive hurdles when it comes to fitting different burners and so on. So it might simply be impractical or too expensive for a 100% switch, and this is where co-firing is something of an advantage. Well, that's all the questions. Once again, can I say thank you very much for your attention. I'd just like to tell you about the next webinar. The next Clean Coal Centre webinar will be presented by Dr. Ian Barnes on the Wednesday, the 26th of July. The title of his report is Prospects for Heli Coal-Fired Plant in Selected Asian Countries. And the countries Ian is studying are Bangladesh, Indonesia, Malaysia, the Philippines, Thailand and Vietnam. So that brings us to the end of today's webinar. Thank you very much for your attention, and goodbye for now.